study fuzzy logic. Now, before going to fuzzy logic, we should know about the theory of fuzzy sets. Now, to know fuzzy sets, we should know some terminologies and basic definitions and terminologies, set theory operations, membership function formulation and parameterization, and membership functions of 1 and 2 dimensions, derivatives of parameterized membership functions, more on fuzzy union, intersection and complement, fuzzy complement, fuzzy intersection and union, parameterized T-norm and T-conorm. First we will study what is the difference between fuzzy set and crisp set. You can visualize the example, then we will go to the set definition. Look at the boundary in crisp set A and boundary in fuzzy set A, which is created by the membership function. Now, characteristics of a membership function is subjective measures, not probability function. The membership function is not the probability function. You will go for the tallness in Asia. So how to measure the tallness? So we cannot give the concrete answer. That depends on the membership function, which gives the answer in between 0 to 1. So the formal definition of fuzzy set a set is said to be fuzzy set in X is expressed as a set of ordered pairs, and the set fuzzy set A is a collection of all points X. The universal set X or universe of discourse, where we are finding the ordered pairs by taking the point with its membership functional value at that point. And since we are finding the fuzzy set A, this is written as mu of A. So fuzzy set A is a set of all points X taken together with its membership functional values at that point. Thus, the fuzzy set is totally characterized by the membership function, which is going to write shortly MF. Now we'll go to fuzzy sets with discrete universe. So we will have an example. If fuzzy set C is equal to desirable city to live in, so X can be found, and from X, if X is given set, you can find C with the membership functional values of elements of X. Similar other example, if fuzzy set A is sensible number of children and you are having the discrete universe 0, 1, 2, 3, 4, 5, 6 like this, and A is a fuzzy set with its the points with its membership functional values. By taking the points of universe of discourse with its membership functional values or membership grades, we can have the graph as shown in the picture. Now we will go to fuzzy sets with continuous universe. Fuzzy set A, fuzzy set B, if it is about 50 years old, then we find the discourse set of positive real numbers which is continuous, because you cannot find the discrete values for the age. Now if B the fuzzy set which are taking the elements from X with its membership functional values. Then if you define mu of X is equal to 1 divided by 1 plus X minus 50 divided by 10 square is shown in the formula, and since it is defined for set B, you are writing mu of B defined on the elements of the set X. So if we are taking using the membership function value or membership function, and we are taking the age from 0 to 100 suppose, then we will find the graph is shown in the figure. By taking different age groups or different ages in place of X, you can find the membership function values or membership grades. Then you can have the figure. Alternatively, a fuzzy set can be denoted as, if X is discrete, then A is the summation of mu A of Xi for Xi in X. If X is continuous, A is equals to integration of mu of X for X in X. Note that the sigma and the summation and integral signs stands for union of membership grades, and the slash stands for a marker and does not imply division. So more definition we study in this fuzzy sets that support core, normality, crossover points, fuzzy singleton, alpha cut, strong alpha cut, convexity, fuzzy numbers, bandwidth, symmetricity, open left or open right, closed. Now we'll find some terminologies in detail which are known as membership function terminologies. Now so you can find from this figure core, crossover points, alpha cut and support. We'll find some set theoretic operations on fuzzy sets. So what do you mean subset in fuzzy sets? If A is a subset of B, then this implies and implied by mu A less than or equal to mu B when you are taking elements from A and B. Complement defined by A complement is equals to X minus C, which implies and implied by mu A complement X is equal to 1 minus mu A of X. And we'll go to union. If C is equal to A union B, which implies and implied by mu C of X is equal to maximum of mu A of X and mu B of X, which will equal to, you can symbolically write mu A of X, that is union mu B of X. Intersection defined as if C is equal to A intersection B, which implies and implied by mu C of X, you can find the minimum of mu A of X and mu B of X for X belongs to the universe of this course X is equal to mu A of X intersection mu B of X. Now graphically, these are the set operations on fuzzy where membership grade or membership functional values are displaying in the course. The first one is A contained in B, then the fuzzy sets A and B, fuzzy set not A, that is complement, then fuzzy set A or B, then fuzzy set A and B. Now it will find some standard membership function formulae. First is triangular membership function, written by trim f of x abc is equals to maximum of minimum of x minus a divided by b minus a and c minus a divided by c minus b with the value 0. So first we have to find the minimum of these two, then we have to find the maximum of the values available. Similarly, trapezoidal membership function, Gaussian membership function and generalized Bell function. These are the membership function formula. And graphically, these are the graphs which shows membership function of different fuzzy sets. Now similarly, sigmoidal membership function is given. It's basically an exponential function denoted by 1 plus e to the power minus a into x minus c, where x is a variable, a, b, c are 3 values given, and these are the graphs shown. For absolute difference of two membership functions and product of two membership functions. The general requirement for fuzzy complements. First is boundary, monotonicity and involution. The fuzzy complements are a different type. One is Sigma complements and Jaeger's complement. The Sigma complement formula is given by SF A is equal to 1 minus A by 1 plus SA. Jaeger's complement and W of A is equals to 1 minus 8 for W power 1 by W. The graphs are given here how they are behaving, complements. Now we'll go to fuzzy intersection with T norm. Basic requirements are boundary, monotonicity, commutative and associative property. Then algebraic product, boundary product, and characteristic product, and minimum of intersection T norm, minimum T norm. Then for the union, T co-norm or S norm. The basic requirements: boundary S of boundary, monotonicity, commutative, associativity. Now the examples are given.
ठीक है ठीक है ठीक है ठीक है।